As now we are recording.
Okay, there you go.
Bringing the spreadsheet back up, and there it is.
Okay, you're good to go.
All right, thank you, Tim.
Y'all need to come downstairs and grab it.
Yes, sir.
Oh, we've got the mean, median, mode, range, mid-range. Let's put the range there. The variance. I hear y'all real good. Please don't be talking while I'm talking, because then I'll have to switch over and find out who's talking and then embarrass you, and I don't want to do that. Okay, so I want you to start, and it's real simple. This is about the lowest that I would give you on a test. This is a test question. And I tell students, when you're doing one of these, don't even worry about the directions. If you can do all of these guys right here, you don't have to worry about my test as far as this material. So I tell students, whenever you're doing a homework problem, don't even look at the directions. Just look at the numbers and do everything. That gives you extra practice on everything. And that way, when you take the test, you will be ready. So go ahead, and it says 8:13 right now. I'll give you a couple of minutes. And if you can't do it, skip it. Just do what you can, and then we'll fill in the blanks after you have a couple of minutes. Okay? So how many of you are going to see Predator Friday? You won't even chase rabbits with me.
You're gonna add. Wait, but that's the. Never mind.
You're right. So I thought they were loving it. Okay, I got that one. So very. So let me get out my
X bar is whatever. I think my graphics I can't do variance.
My little brother took mine and he says that I took his, but I didn't know mine.
Who's gonna get the variance?
I'm looking up what else. Alright.
You'll win on this.
That's what I learned last year. Okay.
The range is highest.
Do y'all hear me? Hello?
Yeah.
Quit talking. Oh.
Wait, we can't hear you.
We can't hear you.
We can't.
Y'all can't hear me.
We don't know what you're saying.
Maybe we should go get that guy.
Go get the guy.
Yo,
It's literally been like 10 minutes.
Oh.
Hello.
Minus. What did y'all get for the mid-range?
It's going in and out.
Yeah, the audio's going in and out.
Somebody plays like a really close to camera. Throw up 2 fingers if we should go get Tim.
Oh, he's gone. He's gone. Can he hear us? He told you guys to shut up. Oh.
Now, I need you to go downstairs and get Tim. And
Hear you.
okay, it must be just a streaming thing. Okay, so y'all gonna have to be quiet so when I'm talking you can hear me. Okay. All right. Thanks. If not, we'll have to go use your phone and put it on speakerphone or something like that.
Y'all have his number? Yeah.
Okay. If you can't hear me, can you hear me now?
Yeah.
Well, let's hurry up and get this over with before something happens and the screen blows up and Sharknado hits. So remember, well, let me go back here. Remember, and we did this the other day. I told you that the mean is equal to the summation of x over n. And then we also said, hold on a second, I got to get the camera right. And then the standard deviation is equal to the square root of the variance. And variance is equal to the summation of x minus x bar quantity squared over n minus 1. All right, so everybody make sure you got those down. We went over that the other day. And let me write it a little bit better over here. Mean is equal to the summation of x over n. And the variance is equal to the summation of x minus x bar quantity squared over n minus 1. And then the standard deviation is equal to the square root of the variance, or the variance raised to the 1/2, or the variance raised to the 0.5 power. Okay? Everybody see that good?
Yes, sir.
Impressed? That's a trick I learned in the war. All right, so let's go back to the spreadsheet and follow what the formula says. So the first thing we need to do is find the mean. The mean is the summation of all 4 numbers divided by what? 4. And I know this is a simple example, but I'm trying to start off slow because we're fixing to make the change between test scores, this data driven, to a frequency distribution. So by the end of the class, you will know how to do a frequency distribution or a frequency table. So just bear with me, because I doubt very seriously some of y'all have seen that before, except on a calculator. So, all right, there's your mean. Everybody check their numbers, see if they got the same thing. These 2 numbers, why am I highlighting those 2 numbers? Of those 2, why? Why do I take the average of those 2 for the median? Because n is even. So those of you that need to write that down, write it down.
What did you take? 405 and 425 instead of 468?
Order. Oh shoot, let me put it in order. I'm sorry. I didn't know they wasn't in order. Sorry. I suck. Hold on. Oh, and thank you. Whoever said that, thank you very much. You're a winner. So.
It's still not me.
With the currency. selection. The heck?
I know, don't pull it. Because my niece is.
How we gonna know?
Don't pull it up, mine ends up. When we what?
Now,
I know what's happening. Y'all know what's happening?
No.
Or talking, y'all are engaging the microphone, which is in my voice up. So that's why y'all can't hear me while y'all are talking. Kind of goes with the same kind of thing. If y'all are talking, you can't hear me talking. So I guess Skype knows what it's doing. But anyway, y'all need to kind of whisper if you can, okay? Because I don't mind you talking with each other, but whisper because it's affecting my voice coming over. So not fussing, just telling you, shut up. All right. I did fix that. Now check it and see. That should be right. Sorry about that. All right, there we're going to take these two, and I'm going to highlight them yellow. For those that from around here is yeller. There we go. And over here, I'm going to hit sum. And I'm going to add those two up. And I'm going to divide by. All right, so that should be your median. Which I really don't care about because it's useless. But in homework points, you need to pick it out, and there's none. So you say none, non-applicable, there ain't none, does not exist. Do not put what?
0.
Put 0, okay? Range. What's the range equal to?
Highest minus lowest.
Oh, y'all are paid attention. I can't believe it. Minus the lowest. And then the mid-range is equal to plus the lowest divided by what?
2.
Plus the lowest divided by 2. Now the variance and the standard deviation, we have to go to our handy-dandy formula. And if you see the formula, it says that we have to take what away from x?
X bar.
We have to take x bar away from x first. So x bar away from x. So equals this number minus the mean, which is x bar. And we always hit F4 right here, Foxtrot 4, to lock that mean, so when we copy down, it don't copy all those other numbers over there. So that's for you Excel people that know how to use Excel. And copy that down, and that's your numbers. And then we need to square it. So we take that number, and we square it, and we copy those down. Let's look at the formula again. What does the formula say after we take x minus x bar and square it? What are we supposed to do to it? The funky E look like? I mean, what does that mean?
You add them all together.
Yep. So I'm going to go down here, and I'm going to sum that up. So we hit the summation key and sum those up. Check your numbers, and that is your numerator for your variance. Write that down. I'll color it dang old aqua. That is your numerator for the variance. So now you go over here and you say equals the numerator divided by, and what is 4 minus 1?
3.
This is 9971, which means absolutely nothing to you, and which means absolutely nothing to me. So we're going to take the square root of it, And that's what means something. So equals this number raised to the 0.5 power. And that is your standard deviation. You can basically say your standard deviation is 100. All right, now let's look at these numbers. This number is important, so we're going to dang over day. And this number is important. And this number is important. Now, those three numbers are kind of all over the place. Why? Somebody tell me why they're all over the place.
Did you have an outlier?
Okay, tell me which one.
240.
240. Everybody write that down. The numbers are out of wampus, out of balance because of the 240. A lot of people don't know what wampus is. When you daggone wash towels and one of them gets to the side and your washer gets out of balance or out of wampus, it starts going wobble, 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 wobble. That's wampus. Okay? For those of you that parents don't teach stuff like that, out of wampus. Out of wampus. W-H-O-M-P-A-S. Wampus. That means out of balance. All right? That's what that means. That means that your numbers are out of balance because of that 240. Okay, that 240 is what you call unusual or an outlier. All right, now it's not going to show up. It might show up depending on how the curve looks, but it might show up as an outlier or unusual. But in your data, a little bit skewed left. But let's go ahead and draw our curve. Okay, I'll try this, and I'm going to try another trick I learned in the war. But I don't know if it's going to work. Let's see. Can I make this transparent? I think I can. I know I can make that transparent. I just can't remember because this is the old program we used to use. Can't remember. No. Use it with the all right, I'll shut up. All right, let's go back. I'll try it with, no, I won't be able to. Well, what I want you to do is I want you to, let's put the mean right here. And I want you to do 3 standard deviations to the right and 3 standard deviations to the left. Who is in this squeaky chair? Okay, whoever's in the squeaky chair, either move or be still. All right, I don't know who it is, so don't get offended because I don't see you. All right, so quit squeaking. All right, so to the right, what are we going to do to the right? Add. Good. Somebody paid attention. And I'm going to lock that, F4, Foxtrot 4. And then I'm going to copy it 2 places to the what? To the right. Right, to the right. Okay. Now, 384 on the left, what are we going to do on the left? So, and copy 2 to the left. And there is your curve. I can't draw the curve because that application is old and it doesn't let me draw a pencil mark over it. So you'll have to draw a curve with the middle being 384 and then first standard deviation. The curve will be like this. Well, I can't do it, but it'll be like this, and then 384 be in the middle, and then 1 standard deviation. So what's an outlier? 684 and above, or 89 and below, 84 and below? So we see that 280 or 240 is what? What is 240?
Outlier.
It's not outlier, but what?
It's not normal or not ordinary or something.
Unusual.
It's unusual. Thank you. It's unusual because it's below 284. 284 to, let's see, hold on. Well, it's unusual. 284 is considered normal here because it's right in here, and normal is here. Low 84, this would be an outlier here, and this would be an outlier here. Okay, anything above 684, anything unusual would be here. So I'm going to color that. I don't like red. I don't like red at all. Gold. And this is unusual. Now, remember I said it might not, it might not, anything above, it might not fit there. Wait a minute. Please, hold on. I'm trying to work here. Leave me alone. All right, there we go. Anything from these right here is considered what? Normal. Okay, so 685 would be an outlier, and 83 would be an outlier, and anything around 84 would be unusual, and anything around 684 would be unusual. But from 584 to 680, from 585 to 684 would be unusual. But this one over here, I'm gonna mark it red, and I usually don't mark things red, but I'm marking it red because it is throwing these three numbers. It's throwing them. It's putting a lot of variation in those numbers. Capiche?
Capiche.
To be able to do with data driven. And I'm going to go over one more, and then we're going to go to distribution. So let's make one up. Let's go with X, and let's go with some ages. Let's go with 5. Well, I'm going the wrong damn way. Sorry. X 21, 24, 25, 26, and 30. 3, 5, 6, and 32. All right, now I want you to do the same thing you did before. Mean, everything on the right over there. I'll copy it down. Put it down here, Control V. And after we do this one, we'll move on to distribution, for frequency distribution. You ever had one of those moments when you ever had one of those moments when you love to tell people, I told you so? Mm-hmm. One of those moments right now. As soon as I finish this recording, as soon as I finish this class, I'm going to write an email. Can't wait, because I was told this couldn't be done. Make sure when you go see Jurassic World or the second one, make sure you notice how short the arms are on the T-Rex, because that's County Tech. Those short arms. I'm going to ask for a chalkboard next year. All right. So this will be x minus x bar, and x minus x bar. Said about y'all. Isn't it? So. Can y'all hear me?
Yes, sir.
Yes, sir.
I thought I got a text that said you couldn't hear me. I'm sorry. Y'all just ignoring me. Okay. But at least you can say you've done something different today. You're ignoring me.
We said okay.
It's nice to be ignored. Okay. You did say, okay, okay.
Did you divide it by distance and something? Because for the original variance, I got 1.5.
Can't hear me.
It's 1 of.
Oh.
Yeah, we got you now.
See, it's I think I need, well, I can't mute y'all. See, that's the only thing. If I mute y'all, then I can't hear you. So, all right, let me do this. I'm gonna mute y'all for a few seconds, and let's see what happens. Okay, I'm talking right now. Is it better? Is it better? Okay, it's better. All right. So what I'll do is I'll just open up the microphone whenever y'all need to ask a question or something, and then we'll go from there. That's the best way I know to do it. All right. So y'all can't keep y'all's mouth shut, so I just have to do it that way. All right. Let's go with x minus x bar. I done got x bar right here, and I'm going to subtract it. And I'm going to go through and do the problem, and then I'll just come back to y'all and ask if you got questions. So x minus x bar. Oh, I'm sorry. I don't need to do that. I need to do the rest of them. I'm sorry. I'm getting ahead of myself. All right, 25.57. That looks like the average. The median, since n is 7, all we got to do is pick the what? The middle. So I'm going to highlight that dang old yellow. And that's going to be equal to that number. It looks like the mode is 21. I really don't care about the mode, but like I said, for standardized testing and for y'all, that's a good, easy point. The range is equal to the highest minus the lowest. And then the mid-range is equal to equal to the highest plus the lowest divided by 2. And the variance, let's go ahead and say equals the x minus x bar, F4. Copy down. Check your numbers, please. And then equals square, and copy that down. And the summation. And the variance is equal to the summation of this divided by 7 minus 1 is 6. And there's your answer. 4 is good enough. 4.2 or 4. If you're wanting to just do it quickly in your notes, you would put 26 right here. And then here you would put 30, 34, and 38, and 42. And over here, you would put 26 minus 4 is 22, 38, 34, sorry, or 20. Dadgummit, I'm going all over the place. Hold on. 18, duh, and 14. Y'all check me, make sure I ain't crazy. But anyway, and if you do it legit, equals 25.57. And over here, I'm going to hit equals this number plus the standard deviation, F4, enter, and then copy over. Okay, that didn't work. Let me try that again. Plus F4. Copy over. And then over here equals this minus F4. And then copy over. All right, I'm going to open it up, see if you got any questions. Well, I'm going to try to. All right, who's got a question about it? Can y'all hear me? Y'all being so quiet. Okay, now I can't hear you. Hot dang it. Hold on, let me try it again. How about now? I can't hear you. I see y'all holding up a 1. What does that mean? Y'all can hear me, but I can't hear you. That sucks. Now I can hear you. What happened? One person, please.
We had to press unmute.
Oh, somebody's up there pressing unmute. Who's up there pressing it?
Aaron.
Y'all good. Good people. Y'all good people. No matter what everybody says. Does everybody have a good feeling about finding this material?
How do we know what to round to if we're on our test?
Okay. When you are doing statistics in general, when you are working on any kind of statistics, you always want to carry your numbers until the 4th decimal place. The very, very, very end, whatever the directions are asking for, that's what you round to. So I always tell students to carry to 4 decimal places. So if you're using an Excel spreadsheet, that's pretty simple. All right, because all you got to do is just format all your cells to 4 decimal places. On your calculator, you just fix it to 5 or 4. You just hit the, mode and fix the not significant. I guess it says significant digits. I don't know what it says, rounding or whatever to 4 digits. Or you can leave it as 10, but it'd be easier if you use the calculator predominantly. Then you might want to use the calculator to round to 4 digits or 5, depending on what you want to do. Does that help answer your question?
Yes, sir.
Always wait till the very end. Do not, when we were getting these numbers right here, like right here, when you get X bar, don't say, okay, well, that's 20.9. Don't do that. No. You do it after you get all these numbers over here. And like I say, all you have to do is hit the right corner, the left corner up here, and then right click, and then go to Format Cells, and go to Number, and go to Number, and then go to 5 decimal places or 4, whatever you want to do. You might have to expand some, but you'll be all right. It only takes a little bit to do that. And see, you don't want to say, well, that's 4.6, so I'm just going to put 4.6, 4.6. No, you do not do that. Okay? Let me cut these out. Hold on a second. Dang Russians. And you see it kind of, and I'll go over here so you can see what they look like over there. There's your. Now, if you got a bunch of zeros, that don't matter. But, you know, like this one right here, like this mean. You don't want to say, oh, that's 25.6, and I'm just going to subtract 25.6 from everything. That's where you're going to get screwed up numbers for your answer. Your answer is going to be like 15.2 for the standard deviation, and the book's going to have 16.1 or something like that. It's going to be a little bit off. So make a note in your notebooks right now that if you see a rounding error, like if your answer is 16.1 and the answer is 16.3, something like that, you've got a rounding issue, meaning that you got to expand your numbers in your calculations to at least 5 digits. 5 digits is usually safe because most of your rounding will be, think about it. What do we think the most of? Money, right? And what is money rounded to?
Nearest whole dollar.
No. What do we think of? When you buy something at the store, what is in terms of? Cents, right? Everybody with me? I meant the hundreds, okay, because of cents. All right, so if something is $125.36, everything's rounded to the hundredth. So that's what we think in terms of. Most of your answers in statistics will be rounded to the tenth or to the hundredth. Most, okay? But you still need to carry to 4 or 5 places just in case. Everybody with me? Oh, there's that squeaky chair again. Can everybody hear me?
Yes.
Squeaky chair is probably throwing off the voice. Okay, now let's go back to this. I want everybody to write these 2 down, and well, I'll tell you what I want you to write down when I get there. There we go. I want you to write down. Now I can write on this. I want you to write down this guy. Best thing to do is take a picture of it, so when I minimize it, you'll have it. So if you want, or you can just write it real quick, either one. Now that between the F and X, put a. I'm gonna take my handy dandy red. I want you to put a dot right here. Dot right here, because I don't want you to think of that as the function. I want you to think of it as F times X. And I want you to put a bracket here and here. And I think that's the only thing I need to do. Now the variance is right here, but what is the difference between the variance and the standard deviation? I'm sorry, it broke up. What?
Square
square to square root.
Exactly. So you don't have to rewrite, reinvent the wheel. If you've got the standard deviation written down, then just cover up the radical, and that's the variance. I don't want you to have to write two formulas. Okay, so go ahead and finish writing those down. And while you are doing that, I'm going to write down an example. Hey, y'all got that written down?
Yeah.
Yes.
Okay, pretty much. All right, so I want you to look at this and write this frequency distribution down. And we'll just call this A. What is frequency? What does the F stand for? It stands for frequency, but what is frequency a 25-cent word for? Head count. So we'll put head count right here. Let's see if you want to sound intellectual. But that is, hold on a minute, this thing doesn't look like it's, is that blurry to y'all or is it clear?
Clear.
Okay. Looks kind of blurry to me. That's maybe because I drank too much last night. Somewhere on this thing. There it is. Manual focus, autofocus. I guess it's on autofocus. Okay. All right, so, okay, look at the formulas on your paper. Tell me what those formulas consist of. F and what?
X.
Where's the X?
It's the age.
It's the age. Okay, how you going to put in T19? How you going to put that in as X? Okay. The answer. I'm not expecting an answer. X is the what? Midpoint. Why do we have to get the midpoint? Then how? We need a single what? A single number to calculate. Can't we calculate 10 to 19?
No.
Because it's a class. It's a parameter. It's a length. Okay. We cannot calculate a measured distance or we calculate from a class limit. We can't, from a lower class limit and upper class limit, we can't calculate that. So we need to we need to make something that we can calculate, and that is the what? Midpoint. So I need y'all to calculate the midpoint, and there's a difficult way and a hard way. An easy way, sorry. A difficult way and an easy way. Leave me alone. All right. The easy way is to calculate the first one. So what is the first midpoint? Well, 10, 19 divided by 2. 10 plus 19 is 29. 29 divided by 2 is equal to 14.5. All right, so 14.5 is our first midpoint. Now, the hard way is to go through and calculate each one of these. Or we can say, what is the class width?
10.
What?
10.
10 and add 10 to each one of these. So 24.5, that's a trick I learned in the war. 34.5. 4.5. I used to have a CO core, and he would say that every other sentence. That's the trick learned in the war, and I guess I just caught on to it. Anyway, he was a hardcore. He was hardcore salty Marine. He was like 4 Marlboro Reds a day and 6 gallons of coffee a day. He was a nasty Marine. But anyway, I'll shut up. So there's your F and X. So now I'm going to take, hold on a second, let me get my other pens. Now I'm going to highlight this area now. Because now this is our new frequency or whatever. I don't even care about this anymore. So now you need to look at your formulas. Now, the mean says for the frequency distribution, mu, x bar, whatever you want to call it, is equal to the summation of what? F times x over what? Over summation of x or what? N. Whatever you want to call it, okay? So what is N, or the summation of F? N is right here. N is equal to 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 3 is 15. 16. Excuse me. Now I want you to put parentheses around this guy because some people see this right here and they get confused. They see it and they go, well, what? Summation of F times X? No. The summation of what? F times X. So what you got to do first? You got to get a column called F times X. So we got to do another column over here. And I'm going to take my handy dandy lavender. Who likes lavender? Squidward. F times X. Don't act like you ain't never watched Squidward. And we're going to multiply 2 times 14.5. And 2 times 14.5 is what? 29? 4 times 24. I'm going to let y'all do that. Okay? And then add those up. Summation of F times X is whatever that is. Now, while y'all are doing this, okay, while y'all are doing F times X and summing them up, I'm going to go to the handy dandy spreadsheet and I'm going to show you how to do this on a spreadsheet. And make sure y'all are working and not playing. I appreciate it. Because I don't want anybody to walk in while I'm doing this historic anti-T-Rex class. And I don't want anybody to say, well, they were in there playing. Okay. Oh, there we go. So I'm going to take my handy-dandy Excel spreadsheet. And I'm going to make a frequency distribution over here to the left. And I'm going to put my classes in, just like I have. So I'm going to show you something. 10, but I'm going to put them in separately like this. 10 to 19, 20 to 29, 30 to 39, 40, 49, 59. And I'm going to go over here and I'm going to put F, just like I have it written on the paper. And that's going to be 2, 4, 6, 3, 1. And then I'm going to go over here and I'm going to do my midpoint. I'm going to check my midpoint, which is going to be X. And I'm going to put equals, equals 10 plus 19 divided by 2. And then I'm going to take that number and I'm going to add, well, it should do it for all of them. There we go. So now I have f of x. So what is the next column going to be? F times what? X equals this times this, and copy down. And I need summations. So I'm going to go right here and I'm going to say summation here. And Control C as in Charlie. Control V as in Victor. And there is your two summations. Check, see what y'all got. So what do you do next? Well, the formula says 522 over what? Over 16. Somebody do that for me on the calculator because I don't want to go through that. What'd somebody get?
32.625.
32.625. Now what does that mean? The average age of these people is what? Or 33, sorry. In other words, the average age that's represented in this frequency distribution is what? 33. Now what does average mean? Average means that the number that's over here is the number that represents no what? No variation. No variation means uniform. Write that down. The number that represents no variation. So if I have all these ages, I got 2 people that are 10 to 19. I got 4 people that are 20 to 29. I got 6 people that are 30 to 39. I got 3 people that, what's the average age? The average age is what?
33.
Now you need to let that sink in. You are finding the mean of a bunch of stuff that you don't know what, you don't even know what the ages are. You don't know how many, you don't know what the ages of these 2 people are. You don't know what the ages of these 4 people are. But you just found the mean of a frequency distribution. Now you can't do it with blondes, brunettes, and redheads. Why? That means I want y'all to interact with me. Why can't you do the mean for blondes, brunettes, and redheads?
Because it's not a numerical value.
Because it's not a class, it's a what?
Category.
Category. Good. Y'all listening that day. You can't do it with category. Category, you can't do it. You can only do it with classes. That means you can only do it with, let me go back here, sorry. I try to go back and forth, and I'm not too good at it. Oh, Russians. There we go. You can only do it. There we go. You can only do it with classes. All right? You can only do it with classes. And remember, the average is the number that represents no variation. No variation is the uniform distribution. And what's the only other uniform distribution there is? In regards to what? What can we not control? Time. So we basically, what we've done is we've manipulated, when you find in the average of data, you're basically manipulating the data to find the uniform distribution. Now, why is it manipulating? Because you are manipulating it. The only one you can't manipulate is time. That's why time always looks like this. Okay. So when you are finding the uniform distribution of any variable, you are basically manipulating. You're finding the number that represents no variation. So 33 is the number that says, okay, out of all this data. Now, what does that mean, Hubert? Well, I'm going to show you. Let's say I've got, let's see, what was this? 10, let me rewrite this, and I'm going to show you. I'm going to show you this, and hopefully, I want you to. You don't have to draw it, but you might want to just let it sink in, because it's good to know. 10 to 19, and let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's good enough. And 10 to 19, the age of 10 to 19 is giving us and then 20 to 29 is giving us 4. 30 to 39 is giving us 6. And then 40 to 49 is giving us 3. And 50 to 59 is giving us 1. Now, what does this indicate right here? You're going from here to there, to there, to there, to there, to there. That's variation. This is variation. This is variation. Okay? Whenever you have breaks or mountaintops and valleys, you have variation. And what the average does is says, okay, well, the average is 33. So we're going to label this thing out around 33, and you just level that out. So you take this off right here, you cut it off, and you disperse it right here and right here. And you maybe, let's say this is up here, you take this off right here, and you put it down right here, or whatever. I'm just trying to let you see that what you're doing is you're making a level field out of a variation. And you're manipulating, okay? You're manipulating the data. You're not manipulating the data, you're just finding, it's like right here. What did we do when we didn't have anything to calculate right here? We used the what? Midpoint. So technically, am I manipulating a little bit? Yes. All right. Some of you females can understand manipulation a little bit more than males can. But anyway, I'm sorry. I shouldn't have said that. I'm kidding. All right. So what you're doing here is you're saying, okay, well, I want to find the number that represents no variation. And that's kind of a little bit of manipulation also. But anyway, that's how you do one. Let's do another one. I'm going to let you do this one. Oh, we hadn't done the standard deviation yet. I'm sorry. Okay, the standard deviation. The standard deviation is equal to the square root of n times the summation of f times x squared, brackets, minus the summation of f times x quantity squared over n times n minus 1. Make sure I wrote down that f times x squared. Let's check it right quick. Sometimes I get it mixed up. So let's go over to the handy dandy whiteboard again. Yeah, f times x squared. Yeah, that's right. This is quantity squared, and you need to make a note of that. Take your handy dandy highlighter and highlight that this is quantity squared. Got that? Quantity squared. And then what is this? This is f times x what? Squared. These two are not the same thing, so you need to make that distinction. All right? F times x squared is not the same as f times x quantity squared. Comprende? Comprende, Hubert. Thank you. Now, let's go back to what was that noise? Okay, where is that noise coming from?
What noise?
Any noise that y'all make in there, it's like amplified. So if somebody's crumpling a piece of paper or if somebody's moving in a chair, it's just making, yeah, that noise right there. What's that noise?
It's the chair.
It's
They're all
all
sleeping.
chairs.
Okay, everybody do not move. There, thank you. Do not move the rest of the class. All right, so look at this right here. What do we need? F times what?
We can't see it.
Oh, I'm sorry, I suck. Hold on. I'm trying, people. I'm trying to do this the best I can. I'm doing this without two monitors. This is okay. There we go. What do we have right here? F times what? F times x squared. What do we have here? F times x. Well, we already have this, don't we? Don't we already have f times x, the summation of f times x right there? Don't we already have that?
Yeah.
Yes, we already have that. We have n. We have f. But what do we not have? I'm sorry, speak up.
F times x squared.
Okay, we don't have x squared. So we need to go back to our handy dandy spreadsheet. And what do we need to do? Have another column. And what's that column going to be called? X squared. Thank you, class. So here is x squared. And equals, I'll do the first one for you. 14.5 raised to the what? Second power. Now that we have x squared, what's the next column going to say?
F times x squared.
Y'all are so smart. I am so impressed. F times x squared. Now be careful here and don't pick the wrong column. F times x squared. And we're going to need that summation. All right, I want you to make sure you put that in your notebook and make sure you put the columns. Make sure you make them very distinctive so you'll know where everything's going. And for stuff to be to the left, it drives me bananas. And underline and bold. There we go. Now, for that formula, that big, intimidating formula, you're going to need n, which is that number. You're going to need f of x quantity squared, or f, the summation of f times x. And you're going to need the summation of f times x squared. So make sure, take a minute and make sure you've got that table completed. This right here is your lower class limit. And this is your upper class limit, which we don't need it anymore, but you need to put this in your notes so you can refer back to it. And this is what's given in the test question. So I'll highlight this, kind of a light green. That's what's given in the test, on the test question or homework question. So you have to add 4 columns. Okay, now I'm going to do this because some of y'all done got your zip fetishes going. So let's go ahead and do the variance. And the variance is equal to n. What's n? 16, Hubert. That's right, class. Times the summation of f times x squared. That's going to be times this number right here. So I'm going to put that number, well, I'm going to try to put that number there. So I'm going to color this yellow and blue. And the reason I'm coloring these is because with all these f of x's and everything, everybody gets confused. So that's why I'm trying to help you out. Minus what? F times x, but I'm going to do what with this number? What am I going to do to it? Look at the formula. Huh? I'm going to square it, yes. Now, what's important for you to realize here? That first number has to be a BA number because you can't have what under a radical? You can't have a negative. So that number in yellow and blue is supposed to be bigger than what? Than the 522 squared. Everybody with me? And then that's going to be over n times what? What? N times what? N minus what?
N minus 1.
N minus 1, which is 15. Okay, now I want y'all to calculate all that right now. Do the top first. 16 times 18, 874, minus 522 squared. And I'm going to do it, I'm going to go down a couple of steps, and I'm going to do it in steps. So equals 16 times. Let's see if that's going to be big enough. Okay, equals this number squared. Is that going to work? Yes, because it's not going to give us a what? It's not going to give us a negative. And then the variance is equal to this number minus this number. What is that noise?
Passing around an attendance sheet.
Oh, okay, thank you. That's going to equal this divided by this. And I think that's wrong. But it may not be. I'll have to check it. But the whole point is, you see that with this formula right here, you see with this formula, well, where'd it go? I lost my form. Oh, it's on the other thing. Hold on. With this formula right here, you need to make sure you have your columns lined up. And we'll go over this when I come back. No, not a big deal. Okay, let me ask this. Since some of y'all are like already packing up and I've got one more minute, so y'all need to sit down. Okay. Anybody got any questions for me? Well, I do appreciate, and I'll make this up to y'all somehow. I'll get some donuts or something for you, for y'all being so patient and so professional, and I appreciate it. Anybody got any questions?
No, sir.
Yes, sir.
You're a good group. Give that paper to Mr. Bowen, please.
It's back here.
Thank y'all. Have a good weekend.
I'm gonna do.
Mr. McClure.
Just keep the pencil.
Okay, Miss Mock, where are you?
I'm right here.
All right. Tell me what's going on. I can't
I was
remember.
working on 3.2 and I clicked to save it to come back to it later, but it turned it in. So now I can't go back and like fix it, and I have a 19 as the grade book.
Well, that means you're going to fail. Hold on. Let me go to my handy dandy grade book. And just watch the board and make sure that hopefully everything will pull up right. Can you see the board okay?
Yeah.
Okay. Course tools. Did Mr. Bowen come back up there?
He's right here.
At your command, I'm walking up
Thank
the
you.
door.
Didn't hit a miss. The only problem, and put this in your middle notes, is that when you're doing this, I think the sound, and let Miss Mock tell you, I don't know, when they are whispering or talking or helping each other work, they can't
Right.
hear me. I mean, but I think there's Miss Mock, is there some kind of problem when there's something going on there?
I think it's just whenever there's like background noise here, like if the chairs start squeaking and stuff, it makes us hard. Like he cuts
Okay.
out.
Okay, all right.
So
Right.
that's something we need to discuss, and that's something we need to take up with Skype or somebody. But anyway,
Okay.
Miss Meredith, Miss Mock, that's your, okay, which 3.2?
Yeah.
And it won't let you do anything?
Like, I went back to review, but it kept saying that if I like worked on a problem, it wouldn't affect the score. So I couldn't like go back and work on, because I got like 2 or 3 problems in and then had to stop.
I'm going to delete it, and you go back and try it now, okay?
Okay.
All right, there you go. Thank you, ma'am.
Thank you.
Mm-hmm.
Okay, Hubert, I'm gonna shut down here and log out, and, I'll see you down in 137.
Okay, text me when you get there because I'm going to invite you. I'm going to invite
Okay.
all the classes at one time. So.
Yeah, it's up and running. Stacy was teaching, so when
Okay.
I'm in the room, I'll just text you.
Yeah, you need to hang up and close everything out.
Right, okay.
All right, bye.
See ya.